Today we'll be looking at using two methods to solve quadratic equation x squared plus 2x minus 15 is equals to 0. And the two methods we'll be looking at include the factorization method and the quadratic formula. We'll be applying two methods in solving the quadratic equation. First, factorization, while the second will be quadratic formula. There are several methods of finding solutions to quadratic equations, including completing the squares, the quadratic formula, graphical methods, factorization, among others. So generally, we'll be looking at the general form of a quadratic equation, which is ax squared plus bx plus c is equals to 0. And we need to take note that a must not be equals to 0, because once a is 0, if you look at the equation, if the ax squared becomes 0 because a is 0, then we'll be left with bx plus c is equals to 0. And that will now make it a linear term. It is a quadratic equation because the highest power of the variable, in this case x, is equals to 2. And for it to remain a quadratic equation, a must not be equal to 0. Now, what are the terms? We have a, which is the coefficient of x squared, because a is multiplying x squared. So whatever multiplies x squared is the coefficient of x squared, and that in this case is a. We have b as the coefficient of x. So whatever multiplies x is the coefficient, and in this case it is b. And we have c, which is the constant term. Constant term could be a number. In this particular case, it could be -5, it could be 5, it could even be 0, it could be 15, and so on. Like I mentioned earlier, we have this quadratic equation because the highest term of the variable, in this case x, is equals to 2. So we'll be starting with the factorization method to solve this quadratic equation. Ax squared plus bx plus c is equals to 0, provided a is not equals to 0, like we mentioned earlier. Our question for today, which we'll be solving, is x squared plus 2x minus 15 is equals to 0. X squared plus 2x minus 15 is equals to 0. We will simply multiply the first term and the third term. Now, what is the objective of the factorization method? What we want to do in the factorization method is to be able to simplify x squared plus 2x minus 15 by breaking it into factors, common factors that can be factorized, and then that will help us in finding our solution. So as we have identified the first term and the third term, we will multiply it together to get a product term. When we multiply x squared, which is the first term, with minus 15, which is the third term, or the constant term, we get minus 15x squared. We bring the second term, which is a 2x term, and we call it the sum term. So the minus 15x squared is a product of the ax squared term and then the constant term. And then the plus 2x is the second term, which is also what we call the sum term. So we have the product term and then we have the sum term. Product term because we multiplied x squared with minus 15, that is the ax squared term multiplied by the constant term. And then the one in the center, which is plus 2x, is the sum term. Now what are we trying to do? We're trying to figure out two numbers when we multiply them by each other, that is the product terms, we'll get minus 15x squared. And at the same time, when we sum them together, we will have 2x. Now let's look at that number 15, courtesy of the product term. We're looking at 15 not because of the third term, but because of the product term. The product term. Now, what are the numbers that can go into 15? 1 can go into 15, 3 can go into 15, 5 and also 15. So these are factors of 15. But what is the best combination that when we multiply it, it will give us minus 15x squared, and then when we add it, it will give us plus 2x. So let's just look at 3. Let's look at 3 and 5. If we multiply 3 by 5, we have 15. But what we are specifically looking at is minus 15. So if we say minus 3 times 5, that gives us minus 15. Let's see if we use that same minus 3 plus 5, will it give us 2 plus 2? And that actually solves it. So our minus 3 and our 5, if we multiply it together in the product, so minus 3x times 5x gives us minus 15x squared. And when we also add minus 3x plus 5x, it gives us the second term, which is plus 2x. So the whole objective is to be able to make a substitution for 2x. And in this case, we have seen that our 2x will be substituted with minus 3x plus 5x. So what we will do is to substitute our x squared plus 2x minus 15, which is equal to 0. We will substitute the middle term 2x with minus 3x plus 5x. And let's see how that works in this particular scenario. So like we said, our 2x is now substituted with minus 3x plus 5x, as we can see clearly. The next thing we'll do is to group the first two terms. When we group the first two terms, we'll factorize. What is common to the first two terms? We have x, and then when we bring out the x, we have x minus 3, and then we factorize the next two terms, 5x and minus 15. What is common to 5x and minus 15 is 5. So if we bring out the 5, we are left with x, and if we bring out 5 from 15, that is divide 5 from 15, we have 3. So we have 5 into x minus 3, and everything is equals to 0. Now, we'll look at this line 3, x into x minus 3 plus 5 into x minus 3 is equals to 0. What is common to these terms before the plus sign? and also the terms after the plus sign. We will see and observe that x minus 3 is common to these two. So we'll bring out x minus 3, and then we are left with x and then plus 5, and everything is equals to 0. So we have simply factorized this particular equation. Remember that in mathematics, AB is equals to 0. That is, A times B is equals to 0 implies that A is equals to 0 or B is equals to 0. You have two terms multiplying themselves and you are equating them to 0. It tells you that at least one of them should be equal to 0. If A is 0, you know that AB will be 0. Or if B is 0, AB will also be 0. So that implies that if x minus 3 into x plus 5 is equal to 0, it tells us that x minus 3 is equal to 0, or x plus 5 is also equals to 0. Now, if x minus 3 is equals to 0, by the time we take the minus 3 to the right hand side, it becomes plus 3. And if we add it to the 0 there, it is plus 3 plus 0, which is 3. So x is equals to 3, or by the time we take x plus 5 is equals to 0, by the time we take the plus 5 to the right hand side, we have x is equals to minus 5, because by the time plus 5 goes to the right hand side, it becomes minus 5. It will meet the 0 there, so by the time it adds 0 to it, it becomes minus 5 plus 0, which is minus 5. So in a nutshell, we have solved for x is equals to 3 and x is equals to minus 5 using the factorization method. Now we'll go to the quadratic formula method. That's very easy. All we need to do is to write out the standard form of the quadratic equation, which is ax squared plus bx plus c, and then identify our a, our b, and also our c, and simply substitute or incorporate or plug it into the quadratic formula. Now we have ax squared plus bx plus c. By observation, what is our a? Our a is 1. By observation, what is our b? Our b is plus 2, which is 2. And by observation, what is our c? Our c is minus 15. A is 1 because a is the coefficient of x squared. And in our particular problem, which is in blue, our x squared is multiplied by 1. So a is 1. If you look at the coefficient of x, b is the coefficient of x. That is, whatever is multiplying x is b. In this particular case, b is equals to 2. And then our c is equals to minus 15. So a is equals to the coefficient of x squared, which is equals to 1. Remember that a is whatever is multiplying the x squared. So that's the coefficient of x squared, and in this case is equals to 1. B, by comparison, is the coefficient of x. That is whatever is multiplying x, and in this case it is plus 2, which is 2. And then c is the constant, and the constant number there is minus 15. So all we'll simply do, now that we have identified a, b, and c, is to substitute it into the quadratic formula. Now a is 1, b is 2, and c is minus 15. And we'll be looking at our quadratic formula. This formula is something we need to have handy. It's a very simple formula. The more we use it, the more we know it, and we won't necessarily need to cram it. It just becomes part and parcel of us. So this is the quadratic formula. Wherever we see b, we substitute and put 2. Wherever we see a, we put 1. And wherever we see c, we will put minus 15. So that will do immediately. So we have minus b, which is minus 2, plus or minus b squared. B is 2, so it will be 2 squared minus 4ac. So it will now become minus 4 into bracket open 1, bracket close 1, and then into the bracket of minus 15, because minus 15 is c. Everything all over 2a, and our a is 1. So we'll simplify it further in order for us to be able to solve for x. So when we solve it further, what we have is minus 2 plus or minus 2 squared. 2 squared is 4. And then we have minus 4 into 1 into the bracket, minus 15. 4 times 1 is 4. 4 times 15 is 60. And then the negative sign before the 4 times the negative sign before the 15 becomes plus. So we now have plus 60. I come again. Minus 4 times 1 is minus 4. Minus 4 times minus 15 becomes plus 60, because the minus sign times the minus sign will become plus, and then 4 times 15 is 60. And then the denominator, which is the value at the bottom, is 2 into 1, and 2 times 1 is 2. So what we now have is minus 2 plus or minus the square root of 4 plus 60 all over 2. Take note of that plus or minus sign. That plus or minus sign is simply the sign to show that every square root has two possible numbers, a positive and negative. And we'll see that shortly. So by the time we simplify, what we have is plus minus 2 plus or minus 64 all over 2. Now the square root of 64 is 8, but it's also plus or minus 8, because plus 8 times plus 8 is plus 64, which is 64. And then minus 8 times minus 8 becomes plus 64, because the minus times the minus becomes plus, and then 8 times 8 is 64. So we'll simplify it further. So we have x is equals to minus 2 plus or minus 8 over 2. And we'll have two sets of solutions, minus 2 plus 8 over 2. By the time we simplify that, we have x is equals to 6 over 2, which is equals to 3. And then we'll do the other part, the negative part, minus 2 minus 8 this time around over 2. And then we have x is equals to minus 10 over 2. Minus 2 minus 8, you are owing 2, you owe another 8, you now owe 10. So we have minus 10 over 2, which is equals to minus 5. So that shows us that x is equals to 3 or x is equals to minus 5. Now we'll just do a quick check. And our quick check is just to substitute the values of x in our original question. X squared plus 2x minus 15 is equals to 0. Now we'll check for x is equals to 3. All we'll do is wherever we see x, we'll substitute it for 3. So we have 3 squared plus 2 into 3 minus 15. We now have 9 plus 6 minus 15. 9 plus 6 is 15. 15 minus 15 is equals to 0. So our value x is equals to 3 satisfies the equation above and is correct. We will quickly check for the other solution, where x is equals to, in this case, minus 5. So in the equation x squared plus 2x minus 15 is equals to 0, we'll substitute wherever we see x, we'll put minus 5. So now we have minus 5 squared plus 2 into minus 5 minus 15. Minus 5 squared is 25 because minus times minus is plus, and 5 times 5 is 25, and 2 times minus 5, that's the second term, is minus 10, and then we have the minus 15. 25 minus 10 is 15, and 15 minus 15 is equals to 0. Thank you very much. It shows us that x is equals to 3 and x is equals to minus 5 are the solutions to the quadratic equation, whether we use the factorization method or use the quadratic formula. Kindly subscribe to this channel if you have gained any form of value. Kindly like and kindly share. Thank you.